In this video, we will talk about rate of decay and rate of growth. Radioactive substances continuously disintegrate and reduce in quantity after a specific time period, and this happens at a specific rate of disintegration known as rate of decay. Similarly, population of an area decreases or increases after a specific time period, and this happens at a specific rate or speed. This also happens with growth of a germ culture in a laboratory known as rate of growth. So we will be discussing in this video about this rate of decay and rate of growth. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. If Y is the amount of material at any instant of time t, then the rate of change of quantity Y with respect to time t is directly proportional to the amount of material present initially. So that gives us dy by dt equals ky, where k is constant of proportionality. When the problem is related to growth, k is positive and we have dy by dt equals ky, and if the problem is about decay or disintegration, then k is negative and we have dy by dt equals minus ky. In the first problem, it is given that 30% of radioactive substance disappeared in 10 days. We have to find how long will it take to disappear 90% of the radioactive substance. Suppose m is the mass of radioactive substance at time t. This is a case of radioactive decay, so we write dm by dt equals minus km, where k is constant of proportionality. To separate the variables, we write dm upon this m equals minus k into this dt. Integrating, we get log m equals minus kt plus constant of integration c. Initially, when t is 0, mass of substance was, say, capital M. Therefore, this equation 1 becomes log capital M equals minus k multiplied by 0 will be 0. So, c will be log m. So, using this value of c in equation 1, we get log m equals minus kt plus log m. According to next condition, it is given that at time t equals 10 days, 30% of the mass disappears, which means that 70% of the mass remains behind. So we write m equals 70% of capital M, that will be 7 upon 10 capital M. By using this value of M in equation 2, we get log 7m upon 10 equals minus 10k plus log m. So that gives us k equals 1 upon 10 log of m upon 7m upon 10. M will get cancelled and we get log of 10 upon 7. When 90% disappears, 10% remains. So therefore, in the next step, small m will be 10% of m, that will be m upon 10. Now we have to find t when m is capital M upon 10. Now we will substitute the values of k and small m in equation 2 and write log of capital M upon 10 equals minus 1 upon 10 log of 10 upon 7 multiplied by t plus log of capital M This will be 1 upon 10 log of 10 upon 7 multiplied by t equals log m minus log m upon 10, that will be log m upon 10, which will be log 10. So finally, therefore, this t will be this 10 multiplied by log 10 upon log 10 upon 7, that will be 10 multiplied by log 10 to the base e will be 2.30 upon log 10 upon 7, that is log 1.43 to the base e will be 0.35. That gives us 64.6 days. So our answer will be, in order to disappear 90% of the radioactive substance, 64.6 days will be required. In the second problem, it is given that the rate of change of atmospheric pressure P with altitude h is directly proportional to the atmospheric pressure P at the ground when altitude is 0 units. Atmospheric pressure is 14.7 units. At the altitude of 10,000 units, pressure reduces to 10.1 units. What will be the atmospheric pressure at the altitude of 15,000 units? dP upon dH equals minus Kp. To separate the variables, we write dP upon P equals minus K into dH. Integrating, we get log P equals minus Kh plus C at H equals 0, P equals 14.7 units. So equation 1 becomes log 14.7 equals minus K into 0 will be 0. So C will be log 14.7. Using this value of C in equation 1, we write log P equals minus Kh plus log 14.7. So Kh will be log 14.7 minus P, that is log 14.7 upon P. In the next condition, it is given that at altitude h equals 10,000 units, atmospheric pressure was 10.1 units. So using this value in equation 2, we write K into 10,000, that is 10,000 K equals log 14.7 upon 10.1. So value of K will be 1 upon 10,000 into log of 14.7 upon 10.1. We have to find atmospheric pressure at the altitude of 15,000 units. So we will use this value of K and H in equation 2 and write 1 upon 10,000 log of 14.7 upon 10.1 multiplied by H, which is 15,000, equals log of 14.7 upon P. 5 2s are 10, 5 3s are 15, so it will be 3 upon 2 multiplied by log 14.7 upon 10.1 to the base e will be 0.3753. That will be 0.5629 equals log of 14.7 upon P to the base e. So we get 14.7 upon P equals this e raised to 0.5629. It will be 1.7557. So P will be 14.7 upon 1.7557, which will be 8.37 units. So therefore, at the altitude of 15,000 units, the atmospheric pressure will be 8.37 units. In the third problem, it is given that population of a country doubles in 50 years. We have to find in how many years it will triple if the rate of increase of population is proportional to the number of inhabitants. If y is the population at time t years, then by the law of growth of population, we write dy by dt equals plus ky. We use positive sign here because the population is increasing. Separating the variables, we write dy by y equals k dt. Integrating, we get log of y equals kt plus c. It is given that initially when t equals 0, population is y0. So we get log y0 equals c. Therefore, this equation 1 becomes log y equals kt plus log y0. So kt becomes log y upon y0. According to next condition, the population y doubles, that is, it becomes 2y0 in time t equals 50 years. Therefore, this equation 2 becomes k into 50, that is 50k equals log of 2y0 upon y0, which will be log 2. So k becomes 1 upon 50 log 2. Now we will use this value of k in this equation 2 and write 1 upon 50 log 2 multiplied by t equals log y upon y0. Now we have to find after how many years the population becomes triple, that is 3y0. So it will be t equals 50 log of 3y0 upon y0, so that will be log 3 divided by log 2. So it will be 50 multiplied by log 3 to the base e will be 1.0986 upon log 2 to the base e will be 0.6931. So this gives us t equals 79.25 years. So our answer will be the population will be triple after 79.25 years. In the fourth problem, it is given that in a certain culture of bacteria, the rate of increase, that is d by dt, is proportional to the number present in the beginning, that is y. It is found that the number doubles in 4 hours. So the question is, how many bacteria are expected at the end of 12 hours? As usual, by the law of growth, we have dy by dt equals plus ky. Separating the variables, we write dy upon y equals k dt. Integrating, we get log y equals kt plus c. It is given that initially when t equals 0, number of bacteria y is say y0. So this equation 1 becomes log y0 equals 0 into k, that will be 0, equals c. So that gives us c equals log y0. Now we will use this value of c in equation 1, which becomes log y equals kt plus log y0. So that will be kt equals log y upon y0. In the second condition, it is given that when t is 4 hours, the bacteria doubles, which means y becomes 2y0. So after putting t equals 4, y equals 2y0, we get 4k equals log 2y0 upon y0. That will be log 2, which gives us k equals 1/4 log 2. Now we will use the value of k in equation 2 and write 1/4 log 2 multiplied by t equals log y upon y0. So that will be t equals 4 times log y upon y0 upon log 2. Coming to our final question, we have to find out the number of bacteria. So we will put t equals 12. So 12 equals 4 log y upon y0 divided by log 2. So 4 log y upon y0 will be equal to 12 log 2, or log y upon y0 to the base e will be equal to 3 log 2. This will be 2.0792. So y upon y0 will be this e raised to 2.0792, which will be 8, and this finally gives us y equals 8y0. So at the end of 12 hours, the number of bacteria in the culture will be 8 times the initial number of bacteria. That means the number of bacteria after 12 hours will become 8 times as much. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.